All right, this is part 2 of how to solve multi-step equations, and it's focusing on fractions. So if you're not comfortable with fractions, how to get rid of them. I've already made a video specifically on how to solve multi-step equations and why we have to use SADMEP order. So if you are uncomfortable with that, that video might help you. And I've also already made a video on fractions. So I would, this is part 2 really. So this is only if you need a little bit more help with different examples. Otherwise, the other video is probably a good idea. This one, you might want to just look at it to make sure that you're getting the right answers on the worksheet if you got one from me. Or it might be helpful to you as well. All right, so, but this is, again, kind of assuming that you've seen the other video, so it's going to move a little faster, okay? All right, so step 1, simplify if needed. Well, if you're uncomfortable with fractions, you're going to want to simplify this, all right? So what we talked about in that other video is that to get rid of fractions, you're going to first need to find the LCD. We're going to need to get the least common denominator, which we talked about in the other video, and then we're going to need to then, after that, multiply by the LCD, or the least common denominator. Multiply the LCD to both sides of the equation to get rid of the fractions. And I'm going to even be more specific to get rid of the denominators, because the denominators are what makes the fraction a fraction. Okay. All right. So in this case, what is the LCD? Remember that the least common denominator is going to be whatever you're going to have to find it for all of these fractions. So in this case, I'm looking for a number that 4, 5, and 2 all multiply to. If I'm really uncomfortable with doing this, I would just start with the biggest of those numbers, which is the 5, and see, well, do all of them multiply to 5? Well, no, they don't, because 2 doesn't multiply to 5. And then I would do the next multiple of 5, which is 5 times 2 equals 10. And I would say, well, do they all multiply to 10? Well, 2 multiplies to 10, but 4 does not, so that's also not going to work. So the next thing I would try is the next multiple of 5, which is 5 times 3 equals 15. 15 doesn't work for 4, so that's not going to work. 5 times 4 equals 20. That works for 2 and 4 and 5, so that's going to be my LCD. The smallest number that works is going to be the 20. And again, if you have a better way of finding the LCD, which you very well might, you do not have to use this method. This is just a method to use as a backup. All right, so my least common denominator is 20. I'm going to multiply the LCD to both sides of the equation to get rid of the denominators. So I'm going to take this fraction and multiply it by 20, and I'm also going to take this fraction and multiply it by 20. Now, this one is a tricky problem because you have to stay aware that on the left-hand side, it's 1/5 times x over 2 plus 3 over 4. And x over 2 plus 3 over 4, this whole thing counts as one factor times the 1/5. So when I'm multiplying by the 20 on both sides, when I'm multiplying this by 20 on this side and 20 on this side, I cannot multiply the 20 to this and then again to this. That would be multiplying by 20 twice on the left side, which is heavy-handed. You can only multiply the 20 once to each side. So that means that I'm just going to multiply the 20 to the 1/5. All right, that is the only thing I have to multiply it by. So this is going to cross cancel, and this is going to become a 4. And so on the left-hand side, I'm going to have 4 times x over 2 plus 3 over 4, because I multiplied by 20 once on the left. On the right, that cancels out and becomes a 5, so that's going to equal 5. Well, now I can distribute that 4. So I know I'm not rid of the fractions yet, but be patient. Okay, so it's going to be 4 times x over 2 plus 4 times 3 over 4. And remember that 4 is just the same as 4 over 1. So sometimes I just write it over 1 just to make it clear that I can cross cancel that top 4 to the bottom 2. So this 2 and this 4 cancel out, becomes a 2. This 4 cancels out with this 4 and becomes a 1. So 2 times x here is 2x. 3 times 1 is 3. 2x plus 3 equals 5. Okay. I have now gotten rid of the fraction, which was making this problem look harder than it needed to be because I was uncomfortable with it. So I have done step 1. So now I can jump to step 2. If there are variables on both sides of the equation, so stop and take a look and see if there are. You should be able to tell that there aren't, so we don't have to worry about step 2. We'll just cross that off, okay? So we're going to go to step 3, which is isolate the variable by using inverse operations. You will need to use SADMEP order. So I'm going to solve for x here by isolating the x. So I need to get rid of the, I need to isolate the x by getting rid of plus 3 first, because by SADMEP order, I get rid of anything that's subtracted or added, s for subtracted, a for added, to the x first. So I'm getting rid of the plus 3 by subtracting it in the inverse operation. That becomes 2x plus 2. And then next, I look for anything that's multiplied or divided to the x, which is times 2. So I'm going to divide by 2. And my answer will be x equals 1. And then we'll do another example. Okay. Example 2. We're going to do one that looks different so that you can get experience with different kinds of things. Okay. So again, step 1 is to simplify if needed. And again, if you're uncomfortable with fractions, you're going to want to do these 2 things to get rid of the fractions. So first, we're going to find the LCD of the partial, which in this case, I look at the denominators, and they are 2 and 5. So I need an LCD of those 2 denominators, which is going to be 10. Okay? I'm going to multiply that LCD to both sides of the equation to get rid of the denominators. So I'm going to just recopy this problem so that I have more space here. So I'm going to multiply this by the LCD of 10 over 1. And remember, 10 is the same thing as 10 over 1. I just changed it to over 1 because then it's easier for me to multiply it by a fraction. And then I'm going to multiply this by 10. I'll leave it as a regular 10, and this by 10 over 1. Notice that I'm multiplying the entire left side by 10 and the entire right side by 10. So this 10 has to be distributed to that first fraction, and it also has to be distributed to that second parentheses, because the 10 gets distributed to everything that's added or subtracted. So every term. So this is the first thing, and then it's going to also be multiplied to that second parentheses. Okay? So you have to distribute it to both terms, the x plus 3 over 2, which is that first fraction, and then the x minus 1. So then here, remember there's an invisible x plus 3, parentheses around the x plus 3 because it's above the fraction bar. That 10 cancels out with the 2 and becomes 5, so I'm left with 5 times x plus 3. This 10 doesn't cancel with anything, so I'm just going to put it in the front of the parentheses instead of the back. And then here, this is going to cancel with that 10 and become 2, so 4 times 2 is 8. I have now gotten rid of the fractions, but I still need to simplify, so I'm going to do that. 5x plus 15. And this is a good place for you to pause the video and see if you can do this on your own from here on out. I'm going to add like terms, so 10x plus 5 is 15x. 15 minus 10 is plus 5, is 8. Subtract 5 on both sides. Oh, this is step 3, because step 2 was to check if there's variables on both sides of the equation, then get rid of them, but there aren't. There's no variable on the second side, so we can skip it. And then step 3 is to isolate the variable, so that's what I'm doing. So to get rid of the plus 5, I subtract 5 from both sides, I get 15x equals 3, divided by 15, and then I get x equals 1. All right, let's do another example. again, it's a good idea for you to try this example on your own at this point and see if you can do it without the video. There was an example like this in the other video, so that should help. Okay. Again, we're going to do step 1, which is to simplify if needed. Again, if you're uncomfortable with fractions, you might want to get rid of that first. So step A of getting rid of a fraction is to find the LCD. So if I look at the denominators, 3 counts as a factor and x minus 2 counts as a factor. So in this case, the LCD is 3 times x minus 2, because anything that has adding or subtracting in it, this whole thing counts as one factor. Step 2, multiply the LCD to both sides of the equation. So I'm going to multiply this by 3 times x minus 2. And multiply this side also by 3 times x minus 2. Over 1, to just make it clear that it goes to the top of the fraction and can cross cancel. So that 3 cancels with that 3. This x minus 2 cancels with this x minus 2. That becomes 3 times 4 is 12. This becomes 2 times x minus 2. So it equals 2 times x minus 2. No more fraction. Looks so much more nice. I've gotten rid of the fraction, but I still need to simplify, so I'm going to do that. So 2x minus 4 equals 12. Step 2 is if there are variables on both sides of the equation, which there aren't, so I can skip that. Step 3 is to isolate the variables. So that's what I'm going to do. I'm going to isolate this x right here. And the first thing I have to do is get rid of anything that's subtracted or added to the x. So that's the minus 4 is being subtracted. I'm going to add that to both sides. 2x equals 16. And then that's 2 times x. So then to get rid of the times 2 for the next part of the order of operations, anything that's multiplied or divided to the x needs to be gotten rid of, is I'm going to do the opposite of times 2, which is divided by 2. And that's going to be x equals 8, written in a more normal way with the x on the left-hand side. That would be my answer. And hopefully that helps you out with fractions, not just on this, in these practice problems, but in future ones.